Is college physics. College physics is broken up into two classes, two semesters. The first semester is all like forces and the motion of, kind of the physics of things that we're used to dealing with. Um, and then the second semester is electricity and magnetism mostly. You get into a little bit more abstract stuff. Um, and the way I'm going to do my lectures here, uh, people seem to like this. So instead of writing up on the whiteboard, I'm going to do my lectures like this. You're going to take notes, on what I don't take that, but, just do it like you would if I was writing on the whiteboard. But the benefit is after class, I'm recording video as I go. So there'll be a PDF of what I write here and a video file that, where you can go back, see my pen writing, hear my voice. And so if you miss something, you want to see something again from class, all of the lectures will be available on D2L. And obviously it's really nice if you miss class, because you don't have to get notes from someone else. You can just watch the video files. One thing I would say is just be sure when you use these video files instead of coming to class, be sure that you do the same things you would do if you came to class, like don't watch it while the TV's on or something, like it's pretty easy to watch these video files and not be concentrating and taking notes the same way you would if you were in class, So other than that, that's always going to be available. Today, I'm going to do, well, two things to start with, and then I think we'll get to some of the actual class. So the first thing I'm going to do is go through the syllabus. And that's just going to lay out, the format of the course, how the grades are calculated. Actually, okay. And it has some information about when the exams are. After we're done with the syllabus, this is something that I think a lot of people coming into this class, I know a lot of people haven't had math in a while. So a lot of people are sort of curious, nervous, like I haven't taken college algebra in 5 years or whatever, like what's the level of math that's going to be here. So I'm going to give you sort of a quiz. You're not going to turn it in, but it's just, for your own benefit, give you some problems that are sort of at the kind of harder level of the type of math that you'll have to do in this class. So basically, if these questions look more or less doable, like, oh, that sort of rings a bell, I think I know where to go in a book and figure out how to do that, then you're probably in pretty good shape. If you look at it and you're just like, I've never seen any of this before, then you probably should come talk to me. So we're going to do the math quiz. And then after that, we'll probably be able to get to some physics stuff today. One bit of information that I put this up on D2L today, but I'm sure not everyone's been to D2L today. There's not any lab this week or next week for a couple of different reasons. So we're going to start off easily, nicely. That's good. So we'll just be here today and Wednesday until 7:20, and then you're done for the night, and next week too. And then on the third week, we'll start with labs, the normal schedule. And before I go into the syllabus, I guess one thing I want to do is, you can drop and add classes all week this week. So while there's still time to switch classes, I just want to say a little bit about the other physics classes that we offer. Basically, there are 4 levels of intro to physics that we offer. And that is a little confusing, you know, because there's just so many options. There's a level that's easier than this. That's physics 1050. Actually, now no, there's one easier. It's not 1050, it's the other one. It's called Physics for Future Presidents. And it's more of kind of like a survey class, not as heavy into calculations. And so if you haven't had college algebra and you're just looking for like a science distribution credit, that's probably the class that you'd be happier in. And then this one requires college physics, college algebra. A lot of people take this class who are getting their prerequisites together for like health sciences professional schools. So a lot of pre-pharmacy people, pre-physical therapy, pre-vet, pre-med somewhat. And then, you know, so usually about half of the people in the class are heading in that direction, and it's suitable for those. Then the next one requires calculus, but it's not like the heavy duty calculus. Like the hardest one we offer is for mostly it's the engineering students who take it.
Physics, right?
Yes. Hi.
I should come.
You should. There aren't any seats left. So the next level higher than this one is sort of like the calculus light physics class, and it's specific for health sciences. So I would say anybody in here who particularly is doing this pre-med and has taken calculus but isn't super excited about a ton of calculus related calculations, you might want to think about that one. That one's physics 1201. This class for people in pre-med, it's fine. The MCAT doesn't go into any math more complicated than this, but it tends to be the case that admissions departments, you know, like if you can do the harder math class, they seem to look favorably on that. So it's something to think about anyways. I mean, I've had a lot of students take this class and get into medical schools, all sorts of medical schools, you know, so I don't think, you know, this class is perfectly suitable, but if you can do the higher one, I think there's reasons to do it. And then the last one is if there's anybody who's taking this class planning to go into engineering, you need to know that this class won't give you physics credit in engineering. I mean, I know a lot of people take this class before they do the engineering physics, and I think it's a good introduction to that stuff, gets you sort of a head start when you go into the engineering physics, but you won't get credit in an engineering program for this physics class. Okay. Any questions about any of those? Yep.
Do you know what the prerequisites are for the next one up?
For the next one up, it's just calculus.
Okay.
Just Calc 1, I'll bet. And then for the engineering physics, you have to have Calc 1, and I think Calc 2 is a co-requisite. Like you can take that as you take Physics 1. Any other questions? Okay. Well, let's go through the syllabus and just talk about the structure of the class. There are 5 sections of this class. Each section is a different lab. So these first 3 sections, 11, 12, and 13, they're all in the same lecture during the day. And then the sections 91 and 92 are you guys. Those are the night sections. 91 is the Monday lab. 92 is the Wednesday lab. And so the lectures are always going to be 6 to 7:20, and the labs are always going to be 7:30 to 9:20. One thing that is useful a lot of times to keep in mind is, so I'm going to talk about my ideas about exams, you know, how we do makeup exams and stuff. But one thing to always keep in mind is if you can't make it to the exam for the night class, but you can make it to the day class that's giving that exam, you're always, like, you don't have to tell me in advance. You're always welcome to just show up and take it with the day class. There's no, I don't have any, that's no more difficult for me or anything. So I know a lot of times people, you know, they won't be able to study as much as they'd like the night before. They'll come to my office hours the night before and sort of feel like they're not ready to take the test. And so they'll just cancel what they're doing the next day and take the test with the day class. So always feel free to do that. Also, with labs, like say you're scheduled for the Monday lab, but 1 week, you know, you can't make it to Monday, you're also always welcome to just come to the lab on Wednesday, as long as it doesn't become a problem. I've never had it become a problem before. I think we can always squeeze people in. So basically, you can look at all of these schedules, find whatever time works best for you that week, and go to that one. Okay, my name is Guy O'Lakin. Oh, and notice, one other thing to notice is if you go to the day sections, the lecture is in a different room. So don't come to this room and freak out and fall down crying, like, why? Okay, my name is Guy O'Lakin. Please just call me Guyo. My area that my PhD is in is engineering mechanics, so it's not exactly physics. It's actually really well suited towards the stuff that we do in the first semester, like this class. I really like teaching this class. The second semester, I mean, it'll go fine. Like, I won't tell you stuff that's wrong or anything, but my research isn't in the areas that we do in the second semester. My office is right upstairs, 2302. And this gives you my email address and my phone number. Email is actually a better, faster way to get a hold of me. Send me an email and I usually get it right away, like it comes to my phone and stuff. If, you know, sometimes I'll get an email and I won't have time to answer it then, and then I'll forget to answer it later. So please, if and when that happens, just, you know, send me another email and say, this is the second email. And then if it's second email, then you get bumped to the top of the priority list because I'm embarrassed. But if you try to say it's your second email, I can look back, you know, if I'm like, wait, I didn't see it, you know, and then that's really bad. So don't lie about it being the second email. Materials for the class, there's no book. I feel very strongly that I can make everything feel sort of streamlined. You get what you need to know from the lectures and from my practice problems. I have, you know, many times had people come and talk to me and say, this class, you know, like I need another source for problems for whatever. And I will recommend a book to you. But my experience is I've never had somebody say, wow, you know, getting that book was really what I needed. I mean, I think you'll find that, like, in my lectures, in my practice problems, I'm telling you the stuff that I want you to try to understand, you know. In the book, you get 200, 500, whatever, extra pages of the stuff that I'm not trying to focus on, you know. And to me, it just makes it a little more confusing. So I would recommend just really trying to focus on the lectures and the practice problems. I think you'll find it goes pretty well if you do that. But if you want a book, especially if you just want a book for future reference, you know, like textbooks are really nice resources for when you go back. Come talk to me. I'd be happy to recommend books. And I have a couple of recommendations that cost $15 or $20. So that's a nice thing too. You know, textbooks are so expensive often. As far as a calculator, you just need one that has trig functions. So as long as you can do cosine and sine, your calculator should be fine. Prerequisites, the only prerequisite is college algebra. And it's probably worth noting that really even the math that you do in college algebra is not really required in this class. Most of the math that we do in this class, you probably cover in like beginning algebra, you know. The prerequisite of college algebra is really meant more as an indication of how comfortable you should be with algebra, you know. We're going to sort of talk about these physics concepts using math in a way that they don't do in the lower level math physics class, you know. The website for this class is on D2L. If anybody has not been on the D2L website, just please get in the habit of going to it, you know, let's say every class period, maybe even every day. Just go to D2L, see if there's anything new in the news items. And so anybody who's new to Normandale and hasn't gone to D2L, that's a really important thing to figure out. Make sure that you know, can figure out what your star ID is, get on that site and get used to going to it. The D2L site is where I'm going to put all the lectures, all the lecture notes, all the assignments, little notes like, you know, for example, it seems to always come up like, I'll give you practice problems where somewhere on some practice problem there's a math mistake and it comes to my attention, maybe a student finds it or something. I'll put that note up on D2L. So those kind of things, it's helpful to know that stuff. Here's a list of all the topics that we're going to go through this semester. We'll talk about measurements and estimating. Basically, that's dealing with different units, physical units. Then we'll talk about descriptions of motion in 1 dimension and 2 dimensions. When we talk about the description of motions of objects in 2 dimensions, we're going to have to introduce this new mathematical idea called vectors. You can think of vectors as the way that you express directions in a space where you can go anywhere. You know, like when you only have 1 dimension, like something moving along a wire, as this thing, like at any point, an object can only go this way or that way, right? Either forward or back. And so when you're talking about directions, it's enough to say 50 meters forward or 50 meters back. But when you go into 2 dimensions where you can go this way or that way or that way, just saying forward and back isn't enough anymore. And so you can try to describe it in terms of, you know, north, northwest or whatever. But the way we're going to do it is by using vectors. And in order to do that, I'm going to have to, you know, define some of the math of vectors, and that depends a lot on trigonometry, and trigonometry is not a prerequisite for this class. So I'm going to have to, you know, give a little introduction to the trigonometry that we're going to need to. And so I know a lot of people in here have never done sine and cosine stuff before, but we'll do that before we need it. Okay. And it's great. I mean, because trigonometry, that's a year-long class. And so I get to do it in 1 class before, yeah, it's perfect. But I mean, we're only going to do a very small, you know, subset of the stuff you learn in a trigonometry class. And after we describe motions, that's kinematics, then we'll introduce the ideas of forces. You can think of forces as the cause of a motion, you know, something that you describe going through an arc like this. There's something pushing it in that arc, and those things are forces. And so we're going to describe forces and talk about the relationship between forces and motion. And that is in the form of Newton's laws. Then we'll talk about circular motion, momentum. We'll talk about energy. And then after all that is done, we'll go from talking about, so for that whole first chunk of the class, we'll be talking about particle physics, thinking about things as if they just existed at a point, and you're just talking about whether that point moves this way or that way. After we talk about energy, for the first time, we'll start talking about rotational motion and talking about objects that have some non-zero size. So we won't be talking about points anymore. We'll be talking about like an object that can be oriented this way or upside down or to the left. Okay, when you're talking about points, there's no such thing as that. And so to talk about orientations of objects, we're going to have to introduce some new ideas. And that includes moments, which are a lot of times called torques. You've probably heard the term torque before. And okay, then after we're done going through all of the physics of rigid bodies, things that can have different orientations, we'll talk a little bit about fluids, like pressure, like what's the pressure that an object feels at the bottom of a 10-foot, pool of water or something. We'll be able to do calculations like that. We'll talk about why hydraulics and pneumatics work. And then possibly, we'll see how far we get. Hopefully, we'll get to vibrations and waves at the end, but we might not get to that one. Any questions about any of those topics? Okay. Okay, so this is the way I'm going to grade the class. I'm going to, so everything is going to be on a straight scale. A's go 92 to 100, and then everything else is 80, 70, 60. It's possible this will be relaxed. I usually don't have to, though. And oh yeah, that's a typo. Yeah, you don't get, it's an incomplete. Yeah, so the B's go up to 91 or whatever. Okay. So I know it's not too unusual in physics classes to have like pretty severe curves on things where people get exams where the class average is a 68 or something, and so a 74 is an A, I tend to feel like a big part of where I want you to get with this material is I want you to, like, I want to, as much as I've been able to, I've tried to remove a bunch of the stuff from this class that I don't want to focus on. I want to have a small number of things that you do focus on, and with that stuff, I want you to feel like you know it, and when you answer, you're not just writing like, oh boy, I remember this equation and this equation. I want it to feel like you answer it and you know that what you wrote is the right thing, or sometimes you write something and it's the wrong thing. But I just want you to feel like a sense of certainty is what I'm trying to get at. And so that's why, relative to other physics classes, this might be sort of a high grading scale. The trade-off is I think my exams are probably sort of on the easy side compared to the physics tests with really horrible curves. But anyways, if nobody in the class is above 92, then I'm definitely going to curve it in some way, Okay. No, because Normandale doesn't. I wish we did, but I don't know. And I try to be sensitive about that when I do the final grades too, like I know how painful it is to get a 79.8 or whatever. So like if you get like a 79.8, you know, I'll give you a B and like a box of tissues or something. Or a C. I ruined that joke. Okay. So the weighting of the final grades, exams are going to be by far the majority of the grade. But when we talk about practice problems and stuff, I think you'll see like they should be pretty low stress exams. The questions I'm going to ask are going to have a very familiar look to them. They're going to be very similar to the practice problems that you've been working on. And then the other things that go into it are lecture quizzes and problem sets. And so now just like one by one, I'm going to go through all these things and talk in more detail about these different things that you'll be graded on. Notice that the final grades don't have any labs in them. So you have to go to the labs to pass the class, but as long as you get credit for the number of labs that's required, then it doesn't factor into your grade at all. I think you'll find that the labs are pretty low key. They're, you know, compared to a lot of bio and chemistry labs and stuff, they don't take very long. You know, like a lot of the labs, most people will be out of there within an hour. You can miss one lab and still pass the class without making that lab up. If you miss more than one lab, you're going to have to make it up, and there'll be a few assigned makeup lab periods over the semester. I would say if you miss more than 4 labs, that's when you'll start to get into trouble with trying to get in enough makeup labs to pass the class. But I don't think I've been doing grading labs this way for 4 years or something, and I don't think I've ever given anyone an F. You know, we can usually figure out a way to get all the labs in you need. No one's failed the class because of labs yet, but you know, try. Be creative. Okay, so homework. There are 2 kinds of homework. One is what I call practice problems, and those you won't turn in. Full solutions are provided for those problems. And those are the ones that are very similar to the questions that are going to be on the exam. So the best way to get ready for the exam, once you've gone through the notes and you understand the concepts and stuff, is to go over those practice problems. And when you're done with it, compare to the solutions, make sure you did it the right way. And if you ever have a question like, okay, well, I got the same answer as you, but you did this and I did this, you know, is that okay? Just bring your notes in to office hours, and I'd be happy to go through them, you know, point by point. I think that a lot of times is a really helpful thing. And say, like, here, I need you to flesh this out more. Here, you know, this is all fine. Okay, so those are the practice problems. You're not going to turn those in. The problem sets you are going to turn in. There aren't going to be very many of those, and they're going to be short. Usually 1 question, sometimes 2 questions. The difference in the types of problems is that the problem set questions are going to be more complicated. So the practice problems, the idea is that at least once you've gotten used to the material, you've gone through these practice problems. Like when you see a question on the exam or a practice problem, you should get to the point where you just know right away what direction to go in, you know. With the problem sets, you might have to do a little more, like try something, oh, that doesn't work, think about it a little bit, come back to it the next day. They're just going to be a little more complicated than anything you're going to see on tests. And it's just, you know, it's a way for me to combine topics and to make you think in a way that for in-class tests, I just really can't ask you to, you know, I think if you ask questions that are too complicated on exams, you start just sort of measuring how well people do under pressure, and I don't really want to do that. I want, on the exams, I just want to measure, have you done this work, thought about these questions in the ways I want you to think about them? But these problem sets, I'll give you like a full week to think about one question, so what am I talking about? This is just like going on and on about nothing. But you know what I mean about problem sets, right? No? Okay. Well, I'm not talking about it anymore. So the way I'm going to grade them is just 0, 1, 2, 3. If you turn in a problem set, or you do the problem set in basically the way I hoped you would do it, you get full credit, 3. If you basically did everything that I'd like to see, but there's one or more like important mistakes made, things that like you really misunderstood this one little part, I would give you 2.5. 2 is, okay, let me start over. So 3 is full credit. That's easy to understand. If I feel like there are important things that you misunderstood, you'd get a 2. If it looks like you forgot that the thing was due and wrote it on a piece of toilet paper 5 minutes before class started, that's a 1. And if you don't turn it in, that's a 0. Then halfway in between there, like say you turn in something that it looks like you understood everything right, but you have, say, more than one math mistake, like your math is just a little sloppy in more than one place. That's the kind of thing that I would give a 2.5 out of 3. Like no important misunderstandings to me, but just not putting the care into it that I would expect. So 2s, 2.5s, and 3s are by far the most common scores. 3s, I'm sure, are the most common score. People can usually get full credit on these if they, put the time into it. One thing about problem sets that I do a little differently is instead of turning these assignments in, like writing them up and dropping them off, during lab on the week that they're due, I'm going to pull people back into a back room one by one, and I'm just going to have you like sort of step me through what you did. It's not like a scary or painful process, but just I want you to point through what you did. It's a way for me to sort of make sure that you're not just copying someone else's work. I can ask a question here or there. It doesn't usually take very long. And then maybe the nicest thing about it is instead of waiting a week or more for feedback on it, I can just give you immediate feedback. I can say like, oh, okay, this diagram here, you need an arrow here. This over here, on the other hand, is fine. So it seems to work pretty well. And so, yeah, you won't have to turn anything in, but I would recommend writing up assignments the way you would write it up if you were turning it in. And then it's a lot easier for you to walk me through what you did. One thing that comes up a lot with these problem sets is people come back into my office and they're like, oh boy, let's see, what did I do? I haven't done this. I haven't looked at this since Monday or whatever. Don't do that. Like if you haven't looked at it since Monday, it doesn't take very long to remind yourself what you did, but just be ready to step me through your thought process as you did it. When, think of it as like a very small presentation. It usually only takes 3 or 5 minutes or something per assignment, but even if you did it perfectly, if you don't remember what you did, then I'm going to give you a bad score on it, and I mean, it's okay to, like, I don't care that it's totally smooth, if you have to take a second to remember what you did, that's okay with me, but just remember that I'm scoring these based on how well you can explain the ideas in the problem set, Any questions about that? Okay. The exams, there are 5 exams. The first 4 are worth 15% of your grade, and the 5th one is the final, and that's worth 20% of your grade. So the final really isn't worth that much more than the other ones, but the final is cumulative. I don't give any makeup exams. So if you can't make it to a class, and like below here, it lists when all the exams are going to be. But so say you can't make it to the exam, to exam 3 on Monday. You can't make it to the day class the next day. Then you get a 0 on that exam for now, you know. And then the way you get to make that up is that at the end of the semester, everybody gets a chance to take a new version of any one exam that you want. Okay, so if you haven't missed any exams, you just get a second crack at one that you think you could do better on, you know, with different questions but the same topic. If you have missed an exam, then you take the makeup for the exam that you missed, and that replaces the 0. And so you can miss an exam and it doesn't have to affect your, it doesn't affect your grade at all. But what that means is if you miss 2 or more exams, then it has a really bad effect on your grade, So be sure that, look at this schedule. Be sure that you can make it to these exams. If you can't, then I guess for sure you need to come talk to me. Maybe it just means that this class isn't going to work right now. Okay, here are when the exams are offered. You can see they're all, I think it's about 3 weeks between each pair of adjacent exams. The makeup exams are December 9th and 10th. Like I said, you can retake any of those. And on your makeup exams, so you take a makeup exam. If you do worse than you did the first time, I'll just take the higher of those 2 scores. So it's not like you're taking a risk to do a makeup exam. And then during our scheduled finals period, that's when you'll take, oh, this is a mistake too. It says exam 5 and the makeup. That's just exam 5 there. I'll fix that on D2L. Okay, any questions about the makeup? Yep.
Do they have the final exam periods already decided?
I think they do. It's always tentative until the last week, but I'll look that up and I'll post it on D2L. Okay. Any other questions about tests? Yep.
Are they mostly multiple choice?
No, it's all just like the practice problems. So I want to see your work on everything, just working through problems. And actually that is a nice segue into lecture quizzes, like the difference between exams and lecture quizzes. Exams are just like mathematical physics problems where I want you to show the steps of how you get to the answer. I'm also going to give lecture quizzes that are just making sure that you're going through the lectures in enough detail. So I'll give you plenty of heads up before I give a lecture quiz, but basically those will be, I think they'll actually be short answer, not multiple choice, but that'll be just like, which Newton's law is related to the phrase, for every action there's an equal and opposite reaction, or something. That could be one. And that would just be something I would have said in the lecture, and I would just expect you to have gone through the lecture enough that that you would remember that. I'm going to focus on the big topics. It's not going to be, like, people tend to do pretty well on those, so don't worry about freaking out about every minute detail, but I do want to make sure that you're understanding the lectures before you go on and start working on those practice problems. Any questions about the quizzes? All right. Cheating policy. Actually, that doesn't. The only way that cheating can come up in this class, because of the way I grade the problem sets, is copying someone else's exam, and that does come up. It comes up pretty often. I don't know what to say. I'd encourage you not to do that, please, because neither of us like it when that happens. But yeah, if there are ways that I can tell if something's copied. I'm sure I can't tell in every case, but if you just copy someone's exam and I find out about it, then what does it say I do? I keep changing it. I think it just says it's taken very seriously. I'm going to, I guess depending on the seriousness or whatever, I would, what we do is bring it to the department, talk it over at a department meeting, sort of decide inside the department what to do. Yeah, so please don't do that. We just had a horrible incident this summer. It wasn't in my class, but in a different class in the department. What a mess. And you know, that's not something you want on your record, and it's certainly not something we want to deal with. Okay, general policies and comments. Outside of the days that there are lecture quizzes and exams and labs, I'm not taking attendance in this class. So if it works for you to never come to lectures and just watch all the lectures on the D2L videos, feel free to do that. And I've had people who only came on their lab days and got A's in the class before. I do think that I'd encourage you to come to lectures, because interspersed inside the lectures are going to be times that we're going to group up, 2 or 3 people, work on problems together. Then I'll go through it on the board. You can compare what you did to what's up on the board. And I think it's a really useful exercise, but I know everybody has busy schedules. And if you can get by, without needing that, then more power to you. Question?
So then our lecture quiz is given during lab?
The lecture quiz is going to be given, that's a good idea. No, I think it'll be given during lecture. It always has been before.
Miss the lecture.
So I'll tell you when the lecture quizzes are going to be. It's not going to be like pop quizzes. So yeah, you'd need to come on those days. But other than that, if in lectures where there's no exam, no quiz, and actually the way I've done it before, and I still haven't decided if I'm going to do it that way this time, is the lecture quizzes are actually like the first page on the exam. So it's all like sort of one thing, but it's just separated into 2 sections, like what you remember about the lecture that isn't worth that many points, and then you flip the page and the exam starts, and that's worth more points. And so then those lecture quizzes would just be on those dates that are given here. Okay. Any other questions? Okay, so that's about attendance. Like I said before, everything's going to be on D2L, so get in the habit of going to the D2L site regularly. And then the last thing is, this is a big class. It's like 140 degrees in here today. Hopefully it won't be like that every day, but just people can get on your nerves. You're sitting next to the same person over and over again and whatever. Just try to take a deep breath and we'll get through it together. Every once in a while, something comes up where someone, says something to someone else and like, ugh, That's not fun. It's a little fun. It's a little fun. Okay, but okay, and that's it. That's what the class is going to be. Any questions about anything in the syllabus before? Yep. No projects. Actually, there. I've been talking to this department at Normandale. I've never done this in a class before, but there's a department called Service Learning, and they deal with like sort of how to get students extra credit or course credit for doing things that help out in the community. In this class, the obvious thing to me would be anybody who'd be interested in tutoring algebra at like a high school or something. I'm looking into how to get some extra credit, probably not a lot of extra credit, but tutoring is just such a nice way to help solidify the algebra for you, which is worth a lot in this class. And also, you know, obviously, like, it's nice to, if we can, you know, help at the school or whatever, that's great too. So if you think you might be interested in tutoring for a little bit of extra credit, come talk to me and we'll figure out how to do that. I think the guy, one of the people from Service Learning, is going to come talk to the class either Wednesday or the next Monday. Well, not the next Monday because that's Labor Day, I think. So there wouldn't be many people here. But anyways, he's going to come talk to the class and we'll figure out more about that. Any other questions? Okay. So the last thing it looks like we're going to get to today is this math quiz that's just designed to sort of see where you are with your math compared to the kind of math that's going to come up in this class. Like I said, you don't have to turn this in, but you can sort of use it to gauge where you are. Okay, so here's the math quiz. 5 questions. And then I'll just give you 10 or so minutes to work on it, sketch out some answers, see if you can jog your memories on some of these. Some are easier and some are harder. And then I'll go through how to do all these. So first, plot the function y is equal to x squared. Second, calculate the slope of the line. Going from the point 1, 2 to the point 4, 3. Third, simplify this expression. A b squared c squared over b to the 4th a square root of c. Fourth, solve this equation for a squared bc is equal to 4c plus b squared c squared. And then the last one, solve this system of equations. X1 plus X2 is equal to 50. And 2x1 minus 3x2 is equal to negative 10. And so to solve this, that means figuring out what x1 is and figuring out what x2 is. And again, what I'm looking for, the point that I think you should be at going into this class is, I'm sure a pretty small number of people are going to be able to go through these and get answers for all of them. But you should have, hopefully, maybe you can do a couple of these, and the rest of them, you remember doing that stuff. You have some rough ideas of how to go about it. That's kind of what I'd be looking for here. If all of this is just total gibberish, then we should talk about that. Okay, so I'll give you 10 minutes or so.